Okay, so in class today we had gone over just the basics of what is an angle in standard position and how to sketch the different kinds of angles, the quadrants, as well as coterminal. So what we're going to do tonight in our video is go over the same topics but in radians. So before we get too far into radians, just a reminder to you that this symbol is theta, and it's one that we often use to represent angles in trigonometry. Some others that you may or may not have seen before that get used is alpha. We also will occasionally have beta, and sometimes even phi. So in our book, these four symbols all just stand for an angle measurement, whether that be an angle in degrees or an angle in radians. They stand for an angle measurement. So if we look at our quadrants, we have quadrant 1, 2, 3, and 4. So in degrees, we have 0 degrees, 90 degrees, 180, 270, and then back around to 360. So when it comes to radians, think of it as a circle, and so we think of it as the circumference of a circle. So a first full circle to get all the way around is 2 pi. So that means 2 pi will be our 360. We still have 0 radians, but 360 would equal 2 pi. So then we go and we divide it evenly up between the four quadrants. So if 360 is a full circle, then half a circle has to be pi, because that's half of 2 pi. A quarter of a circle would be 2 pi divided by 4. So 2 pi divided by 4 would give us pi over 2. And then 3/4 would give us 3 pi over 2. And that's how we pretty much get our quadrantal angles. Quadrantals are the angles that are on the axis. Is all by just taking the circumference of a full circle, knowing that that's 360 degrees, and dividing it into fourths. So to find all the little radian angles throughout the rest of our circle, we use this conversion that one full circle is equal to 360. And when you simplify that down into a unit, 180 degrees over pi is equal to 1 radian. And then vice versa, pi over 180 degrees is equal, I should say pi radians, is equal to 1 degree. So these are our two conversions that we'll use to convert a degree to a radian or a radian to degree. So that's actually what we're going to do first, is just go over, I know you guys have done this before, but we're just going to go over a couple to make sure we remember how to do it. So we're going to convert degrees to radians. So 90 degrees, we're going to convert. We're also going to convert 30 degrees, negative 120 degrees, and 60 degrees. So these are the four, and I'll move this up here, that we're going to convert from degrees to radians. So starting off, I have degrees on top. So when I multiply to get radians, I need my radians on top and my degrees on the bottom. So that way I can cross cancel my units. So we have 180 degrees equals pi radians. So we're going to be using this conversion down here. The units will cross cancel. And then our numbers can also reduce, because 90 is over 1. 90 and 180 reduce to 2. So when we multiply across the top, we get pi radians. And on bottom, we get 2, which matches what, logically, 90 should be. So again, for 30, we're going to multiply it by pi over 180, so pi radians over 180 degrees. Remember to think of the 30 degrees as over 1. So cancel the degrees. The numbers can also reduce to 6. So when we multiply, we'll get pi over 6, with radians being our unit that's left. For negative 120, so again, we multiply by pi over 180. So we again have radians on top, degrees on the bottom, so that the units will cancel. 120 is over 1. Degrees cancel. We can reduce as well. So we can reduce both the 120 and the 180 by 60. So it goes into 120 twice, and here it goes in 3 times. So on top I'm left with a negative 2 times pi, and on the bottom I'm left with a 3. So we would have negative 2 pi over 3 radians as our converted measurement. And then the last one, again, we'll multiply by pi radians over 180 degrees. 60 is over 1. Cancel the units, and then 60 and 180 can reduce to 1 and 3, so we end up with pi over 3 with radians as our unit. Okay, we also can go the other direction, so convert radians back to degrees, because sometimes if we're working with degrees, or if we want to work with degrees, we want to go the other way. So when we're converting radians to degrees, we're going to use the other, we're going to flip our fraction so that way degrees is on top, radians is on the bottom, and the radians as units will cancel. So we're again going to do 4 here as well. We're going to start with converting 4 pi over 3 radians. We're also going to convert 1 radian as well as 3 radians. So for our first one, again, because we have radians now, when we multiply, we want radians on the bottom and degrees on top. So that's going to move our pi to the bottom and 180 to the top. So when we cross cancel the units, we'll be left with degrees. So when we also look at what can reduce, 3 and 180 can reduce. So that would give me 60. The pi's can also cross cancel. So when I look at what's left, I have a 1 on the bottom. So in other words, my denominators completely went away. On top, I'm left with a 4 times 60, so that would be 240 degrees as my converted measurement. Okay, now even with number 2, 1 radian, we still have to multiply by 180 over pi. 1 is just a 1. It doesn't mean pi. So when we see something like 1 radian, that means they've actually multiplied the pi in there. So we're doing 3.14 blah 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 times something to give us 1. And so this is actually not a degree. It's not it is a radian. It just doesn't have the pi because they've already multiplied the pi into the number. So when we do this, we still will cross cancel the radians. And so when we multiply, we end up with 180 over pi degrees. So this is where we want to go to our calculator and actually get the decimal. So we would take our calculator and we would figure out what is 180 divided by pi. and I would use the pi button as opposed to 3.14 because you'll get a more accurate answer. So when you plug this in, this is 57.3 degrees, and I'm rounding to the nearest tenth. So when you have a whole number radian, or even just like a 2.3 radians, so a radian measurement that doesn't contain pi, it just means that you're going to have to actually divide pi to get your new decimal answer. It's not going to be a nice whole number degree measurement. So let's do another one with 3 degrees. Oh, sorry, with 3 radians. So we'll multiply it by 180 over pi radians, so that way our radians can cancel. So the units cancel. 3 times 180 will give us 540. And then we still have pi on the bottom, but we're in degrees now because our radians canceled. So 540 divided by pi gives us 171.9 degrees. So again, I rounded to the nearest tenth. The reason I wanted to make sure we go over these is because you do have a test question that's going to give you a whole number radian as opposed to a radian with pi in there. Okay, so that's our basic conversion. What I wanted to do next was to go over more of these whole number radians, because again, they do show up on your test, and that we want you guys to be sure you get these. And here we're just going to estimate how many radians we think are in this picture. So if I give you an angle in standard position, and I want you to estimate how many radians that is. So the first thing in my head is, let me draw or sketch my x and y axis. So sorry, it should be right on there. So I know in radians that this is 0 and this up here is pi over 2. So when I think about the decimal values, pi over 2, if I actually plug it into my calculator, is equal to 1.570796, and it continues on. So when I look at this and how my angle is situated, to me it looks like I'm about halfway between 0 and pi over 2. So then I could take this number and figure out what's about halfway between 0 and pi over 2. So I could say this is approximately 0.785 radians. So in other words, we're getting a numerical value without pi in it. So we're multiplying the pi in there or dividing the pi to get our actual measurements. So if we were to look at, say, one like this in standard position. So again, the first thing I would do is draw my x and y axis so I have an idea as to the quadrant. So when I look at this, if I'm starting from here, from my starting 0 all the way around, I'm going to be between 3 pi over 2 and 2 pi because of the quadrant I'm in. So if again I think of those in terms of decimal value, 3 pi over 2 is about 4.712388, and it continues on. And 2 pi is 6.283185 dot dot dot. It keeps going on forever. So I know my estimated here will be somewhere between these two values. So because this isn't quite halfway, I might say, oh, I'd say it's about 5 radians. And so when we estimate, we're not going to be accurate. We're going to be, it's a good guesstimation as to what it might be. If you wanted to, you could even have gone the other direction and said, okay, if we start here and go downward, we'd be between 0 and negative 1.57 blah blah blah. I could say, oh, this is at about -1 radian. Either answer would work. It just depends on your direction that you go. So you are going to have a question on your homework as well as on the test where you're going to have to look at an angle and estimate the radians. And when you do that, you want to think of them in terms of their numerical as opposed to the fraction with pi in there. And we can definitely go over more of these if it's still a little iffy for you. Let's see. The last thing I wanted to talk about in terms of radians was coterminal. So I know we talked about coterminal and when we talked about our degrees. So now we're just going to talk about the coterminal in terms of radians. So just like in our degrees, coterminal would mean if I had an angle, let's say this was 20 degrees, this would be one angle. The next coterminal would be all the way around and back up, so we would do 360 plus our theta or our alpha. And then we could also do 360, actually I have that backwards. We would take our theta or alpha and add 360 to get a coterminal, and theta minus 360 to get a coterminal. And we could do this as many times as we want. We can, just as long as we keep subtracting 360 or adding 360, we will continue to get coterminal angles. Well, when it comes to radians, we would just take these thetas, our angles, and we would add 2 pi, because that's the equivalent 360 for radians, or subtract 2 pi. And just like in degrees, we can add and subtract 2 pi as many times as we need to find coterminal angles. So like what you did in the degrees, you're going to be asked to find one positive and one negative coterminal angle. So if I were to give you pi over 3, and I wanted you to be able to find one positive coterminal angle and one negative coterminal angle, I would start by taking pi over 3 and I would add 2 pi. That should give me another positive coterminal angle. So we have to remember our fractions. Pi over 3. Now 2 pi, if I need to get a denominator of 3, that means I had to multiply top and bottom by 3, making this 6 pi over 3. So I can add them together, and 7 pi over 3 would be my positive coterminal. Now for my negative, I would take that same pi over 3, but now subtract 2 pi. So again, common denominator, minus 6 pi over 3, negative 5 pi over 3 would be my negative coterminal angle. So it's the same idea as what we did in class, except that now you're doing it with radians, adding and subtracting 2 pi. And so that's pretty much all we're going to do for now, is we'll deal with radians. tomorrow in class if there's questions or clarifications that are needed, especially on the estimating, because I don't know if you guys have done that in Math 3. Please come with questions. I'm more than happy to go over it again to make sure you guys have it.